Hi, physics. Mr. Janowski here. This is the other problem from Chapter 8, Homework 3. So the second problem from that. And this is the one that we did in class today, has a we do problem. So what's going on here? We've got Charlie rolling on a dolly, so like the little scooter things you used in elementary school gym class, basically a skateboard, towards a cart of textbooks. So imagine a rolling file cart loaded up with textbooks. Charlie and the dolly have a combined mass of 65 kilograms, and the cart of textbooks has a mass of 30 kilograms. Charlie's initial velocity is 3.25 meters per second. When he collides with the textbook cart, he grabs hold of it, and they roll off together. So this is a perfectly inelastic collision because you're starting with two separate objects at the beginning of the problem, and they end up stuck together at the end. So perfectly inelastic collision. And what we need to figure out is what is the final velocity. So you grab your red pen and you do, oh, there it is, step So what are we looking for? We're looking for the final velocity. So the velocity of Charlie and the textbooks when they're stuck together, final, which is a lot to write, and we don't actually need to be this specific with our subscripts because at the end of this problem, there's only going to be one mass. It'll be Charlie and his dolly and the textbooks on the cart all together has one big mass. So there's only going to be one final velocity. So let's save ourselves a little bit of effort and call it V sub f for V final. And this is equal to question mark, and its units, of course, will be meters per second because it's a velocity. Now, when you're doing a conservation of momentum problem, and in fact, when you're doing any kind of conservation law problem, your step one is to make a sketch, but you're actually going to make two sketches. You want to make an initial sketch, which matches with the left side of the equal sign here, and then you want to make a final sketch, which matches with the right side of the equal sign. So our initial sketch, what have we got going on here? Initial. Well, we've got the ground. We've got a dolly. Charlie is kneeling on the dolly. And he's moving to the right. So there are speed lines behind him. He's going to collide with a cart of textbooks, which is really kind of tilted and kooky looking, but you get the idea. So these are textbooks sitting on this cart. We know that mass of Charlie is 65 kilograms, and the mass of the textbooks is, that's an equal sign, is 30 kilograms. We know velocity of Charlie initial is 3.25 meters per second. And we know that the velocity of the textbook's initial is, well, look, there's no speed lines. The textbooks aren't moving. So it's 0 meters per second. So that's our initial sketch. And again, this is the left side of the equal sign. That's what is going on there. And then we have a final sketch. In our final sketch, we've got a dolly. We've got Charlie. And Charlie is now holding on to our cart of textbooks. And so after they collide, everything is moving. So here's lots and lots of speed lines for this. Now, the key to doing this problem is to realize what does it mean for things to be stuck together mathematically. So picture, in the picture, they're stuck together. Mathematically, you stick things together using parentheses. So mass of Charlie plus mass of textbooks stuck together with parentheses is equal to, well, 65 kilograms plus 30 kilograms is 95 kilograms. So, yeah, that's our final mass. The parentheses, mass of Charlie plus mass of textbooks. And we're also going to care about velocity final. Again, you can write velocity of Charlie plus textbooks in parentheses final, but save the effort. Just write velocity final. There's only one thing moving. There's only one final velocity. And that is equal to, well, question mark. This is what we're looking for. We don't know what this is. So question mark meters per second. The next thing you do, your step 2 in a momentum problem, at least in one of the long ones, is to write the law of conservation of momentum. So I highly suggest you do that. Just literally copy it. Show your physics teacher that you know what big principle you're going to use to solve this problem. So sigma p initial with a hat plus j external with a hat is equal to sigma p final with a hat. Now, again, the left side of this is your initial sketch. So let's start with j external, external impulse. This problem, we don't actually have any external impulse. External impulse would be Billy, shoving Charlie with 55 newtons for 3 seconds or something like that. That would be some extra momentum we're getting from outside of our system, external impulse. But we don't have anything like that. So this is just going to be 0. Now, so that's going to be plus 0 equals sigma p initial. Okay, look at your initial sketch, figure out all of the things that have momentum. So certainly Charlie does. So p sub Charlie initial. And I'm going to write plus p sub textbooks initial with a hat. Now, here's the thing. The textbooks aren't moving initially. So they have no initial momentum. So that's just going to be 0. I could have saved some time by not writing that, but I wrote it here because in general, when you're doing these problems, it is possible for both things to be moving. So I'm showing you how to do this. So I'm showing you just include all the terms. And then now we realize one of them is 0, so you cross it out. But yeah, it is possible. The cart could have been, rolling to the left towards Charlie, for example. But in this one, it's 0, so you cross it out at 0. Now, the right side, sigma p final, well, look at your final sketch. Where is your momentum? Well, we've got one big mass with momentum. So our final momentum is momentum of Charlie and the textbooks stuck together with parentheses, final, with a hat. And now, just to clean it up, because I got a lot of stuff going on here, a couple zeros, we'll just get rid of those. P sub Charlie initial with a hat is equal to P sub Charlie plus textbooks stuck together with parentheses, final, with a hat. Now we grab our green pen and we're on to step 3. Step 3 is the math. And the first part of the math in any problem involving vectors and vector hats is going to be to take off the hats and put in the signs. Now, in this particular problem, the hats didn't do a whole lot for us. We didn't actually need them. Because in this problem, everything is either moving to the right or it's not moving. So all of our momentums are either positive or they're 0. If we had a situation where something was moving to the left, then the hats would be more useful. In this one, they don't matter. But I'm showing you how to do it in general. Just do the hats, and then, if they're useless, they were useless. Doesn't really hurt you. So P sub C initial, Charlie was moving to the right. So that gets a positive. So P sub Ci with no hat. And then P sub C plus T in parentheses, final. That's also moving to the right. So that's a T. Yep. Won't do. We've lost the hats, and both things get pluses. Now your next step should be replace all of your P's with MVs. So we're going to use this idea. And also, if there were external impulse, if we still had a J in this problem, here is where we would replace the J with FT, but we already got rid of the J. So there ain't no J, so just get rid of that idea. But yeah, now we're going to replace the P's with MVs. So P sub Charlie initial is mass of Charlie times velocity of Charlie initial. And P sub Charlie plus textbooks in parentheses final is going to be, in parentheses, the mass of Charlie plus the mass of the textbooks. So that's our big mass stuck together with parentheses times V final. So that's what we've got. Now remember, we're trying to get V final by itself. So to do that, we've got to divide both sides by this term. Make sure you get your algebra correct and you put it into your calculator correctly. So one way to do that is parentheses. So mass of Charlie plus mass of textbook over here on the other side. Now we cancel these guys out on the right side. So on the right side, we just have V final all by itself, which is what we wanted. So I'm going to rewrite this, and I'm going to switch left and right. And that's going to give me V final is equal to mass of Charlie, velocity of Charlie initial, divided by, in parentheses, mass of Charlie plus mass of textbooks. And we know what all of these numbers are, so we've just got to plug them in correctly. Mass of Charlie, 65 kilograms. Velocity of Charlie initial, 3.25 meters per second. And then mass of Charlie plus mass of textbooks stuck together with parentheses. Don't know how many times I've said that in this video. Yeah, that's 95 kilograms. Now, if you do all of this and you get your algebra correct and your calculator work correct, you're going to find out that this is equal to some number that to three significant figures is 2.22 meters per second. Then you put a box around it so your physics teacher knows that that's your final answer. And then, of course, you grab your red pen and you do your step. Remember, we wanted V final with units of meters per second, but we have V final with units of meters per second, so that's good. Is 2.22 meters per second a reasonable speed for this? Well, that's about 2 meters per second, so it's about 4 miles per hour, which is a reasonable speed for Charlie on his dolly moving with this cart of textbooks. So that makes sense. Notice also that our final velocity of everything together is a little bit smaller than our initial velocity of just Charlie. And if you could picture this happening in your brain, watching this happening for real, that should be what you're picturing. That should make sense. Because the idea here is, again, this left picture is the left side of our equal sign in this expression, in the law of conservation of momentum. So sigma p initial with a hat plus j external with a hat, which was 0 in this problem, but I'll just leave it. So yeah, this right here is that. This right here is this, sigma p final with a hat. And the law of conservation of momentum tells you you've got to have an equal sign between them. Both of those circles have an equal amount of momentum within them. That's the law of conservation of momentum. So initially, all of that momentum, Charlie had it to himself, and he was moving at 3.25 meters per second. So 6.5 miles per hour, 7 miles per hour. After the collision, when everything is together, now Charlie is sharing his momentum with the textbooks and the cart. So he has lost some of the momentum. He's got to share it now. The result of that is the final velocity is a smaller number, 2.22 meters per second. So about 4.5, maybe 5 miles per hour. So something like that. So that intuitively should make sense. And that is the second problem from homework 3. Hopefully you found that helpful.